Geospatial Computing for Business and Agriculture. I'm Tonya Hall, and joining me is Dr. Shashi Shekhar, McKnight Distinguished University Professor at the University of Minnesota. Welcome, Dr. Shekhar.
Thank you, Tonya. Really glad to be part of your show and share some of my work with your audience.
So, give us a brief summary of your professional resume, if you will.
Sure. So currently, I am with the Faculty of Computer Science at the University of Minnesota. And most of my research is focused in this broad area, which you can call spatial computing or spatial data science. So I have teaching responsibilities. So I teach courses on spatial computing and this semester on spatial data science research. We have large research portfolio with many grants from National Science Foundation, Department of Defense, Department of Energy, and so on, in wide variety of areas. So looking at spatial data science for smart and connected communities, I'm co-directing a large grant. We have other NSF grants for spatiotemporal informatics for transportation science, trying to reduce emissions from car. Department of Energy grants in a similar area to exploit spatial data to improve energy use and emission. And a Department of Defense grants to analyze ship trajectory data for evasive patterns and so on. And there are other grants in the related area. I also have fair amount of service activities. So nationally, I'm on the board for Computing Research Association, which is a group of all the computer science research group in the nation and its advocacy to the government. And also on the board of National Science Foundation, Midwest Big Data Hub, which coordinates the big data activities in Midwest area where there is a lot of agriculture and spatial data around water and so on.
Define geospatial computing for us.
Wonderful. So in a very broad sense, you can say this intersects computing technologies with geospatial. That's a simple way to think about it. And in many cases, people will take existing computing technologies and they will use to analyze geospatial data. And that's a very good start. It takes you quite far. But once you dig deeper, we start to find that many of these one-size-fit-all computing technologies, they don't work very well for spatial data. So we often have to generalize those technologies to do better. And in some sense, today's spatial computing is much more focused on these generalizations of one-size-fit-all computing or machine learning or AI to better solve geospatial problems. And as we talk along, I can give examples of those. And the book that we will talk about gives many examples.
When considering the global positioning system at a planet-wide scale,
Yes.
What are some of the disconnects between the systems of different nations and continents?
Wonderful. So positioning, as you know, is a really very old problem. Even going back a few hundred years, when ships started crossing Atlantic, people had to position them on the ocean. When you can't see landmarks, it's hard. You could locate it on latitude, by the angle of the sun, but longitude was a really hard problem. And there was a longitude prize a few hundred years ago, equivalent to the Nobel Prize, to develop technologies to solve it. So today, one of the most popular system is popularly known as GPS, which is the US system. It was developed for Department of Defense, and many of us are using it. But it has now become so critical that many other nations have developed their own. So Russians have their own GLOSNAS, European Union, China, Japan, India, and so on. So broadly, they can use different, say, coordinate systems. So the way we measure position like latitude and longitude, it depends on the coordinate system we are using, right? So if we model the Earth as a sphere, then there is a unique sphere which best fits the Earth, and we can all agree on that. But it's not very accurate if you're doing local measurements. So people have better approximations of Earth as ellipsoids, but those are not unique. There are hundreds of these ellipsoids, and each country picks one which best fits their area. So GPS uses ellipsoid, and the ones which are used by other countries may be different, right? So that's one thing. Fortunately, there is a good collaboration in this space. So many countries have tried to join together and develop ways where a single receiver can exploit the systems from many countries. So GPS is the name for US system. The technical name is actually GNSS, Global Navigation Satellite System. And you can have maybe 6 or 7 are already around. So those protocols are being developed to sort out the difference in, for example, coordinate system. Also, but there are other differences as well. So for example, the strength of the signal. The US GPS, as you know, the signal is not powerful. If you go indoors, right, in a concrete or brick building, the signals are very weak. So in US, we have to complement that with Wi-Fi and other technology. But some of the newer systems, particularly in Japan, are being developed that they have enough power and use the frequency so that it can have better reception indoors. So there are differences of that kind. Also, the coverage is different. Some systems are truly global, like Russian or US. Some are regional. So if you look at Indian or Chinese system, I believe even Japanese system, it doesn't cover the entire Earth. They only cover their neighborhood or their areas of interest. So there are differences, but fortunately there is collaboration in that space. There are already some receivers which can work with 2 or 3 systems. They are already in market.
How can we use spatial data to overcome these disconnects, like between the two different GPS systems?
Okay, great question. So so that, there is a good collection of these coordinate systems. And if you look at the popular GIS software from ESRI, Environmental Systems Research Institute, this is called the ArcGIS family. So software like that can understand hundreds of these coordinates and they can translate between those. And in fact, other softwares similarly have adopted that. So if you looked at Postgres, PostGIS, a database software, or Oracle Spatial, so these libraries have now become very widespread thanks to the early work in GIS. So these kinds of translations are not hard. You need further agreement because these signals are sometimes also encrypted. So that's why the countries, there is a policy level issue as well, and the countries have to agree to share the data and make it usable in different ways. For example, in China, if you look at their geographic data, so sometimes they add errors deliberately because they don't want others to use some of their geographic data. They think it's very, very sensitive. Same way in US GPS in early days, the entire signal was encrypted. So civilians had no access till I think President Clinton's time it was opened up. Right? And even then there were 2 bands. One was protected where you could get better spatial accuracy only for defense. And there was a civilian band which was not as accurate. So there are other kinds of issues beyond data format. That's why policies are important.
What are some of the real world use cases for geospatial computing that maybe business leaders might be able to exploit today?
Sure. So there are some which businesses are exploiting and all the consumers are benefiting. I would suggest, for example, navigation applications. If you think about Google Maps, Apple Maps, Waze, I mean, they need a number of technologies in this space, right? They, of course, need a location technology, which started with GPS and now Wi-Fi indoors. They also need digital road maps. And a lot of those were developed by Census Bureau, Department of Commerce in US for their own work to go and knock at doors to do data collection. They were, not very topologically accurate. So in 90s, startups were formed to clean those up. And today, companies like Apple or Google, which really think that data is valuable, employ hundreds of people to clean it up. Right? But roadmaps came from there. GPS came from Department of Defense. And so similarly, a lot of these technologies have been commercialized. Another big use now is ride sharing. If you are using Uber or Lyft or Didi Chuching or Ola in India, again, they cannot function, right? They need to know the location of driver. They need to know the location of the person who is requesting it and match it up. So they use positioning. They use the road maps, and they actually create new maps of pickup points and so on. So these 2 are very, very, I would say, consumer familiar applications. But there are other uses. In fact, right now, the biggest growth is happening in agriculture. So precision agriculture, which started in late 90s, they put GPS on tractors and they were mapping farms at high resolution, 10 meter by 10 meter to a pixel. And this was to reduce the input because they could map the soil quality. And then some area soil is rich enough, you don't need to put fertilizer as much. So you can reduce fertilizer use, reduce runoff to water. And actually the yields went up because you could adjust seed density by the soil quality. And now this has translated into what is called prescriptive farming. So many companies are advising farmers. In the US, I guess the largest input cost is seed. So companies are advising and saying, okay, this area of your farm soil is better, put more seeds per unit area there. But the other area is not as good, put fewer seeds. So that's growing by leaps and bounds, big takeovers and stories. And there are other areas that's happening. We are commercially, in fact, McKinsey Big Data Report in 2011 projected a value of $600 billion per year by this year, 2020, just by exploiting location traces data. So my guess is, Uber, Lyft, and so on, you can add up their market value or annual revenues. It still hasn't covered that. And just last year, National Academy report estimated a value of 1.3 trillion per year by exploiting remote sensing and other data for energy exploration and generation and so on. So commercial value is large, and almost every large company you know of is playing in this space. Whether you call tech companies like Amazon or Apple. Like Amazon, remember in mid-90s when they started, Jeff Bezos said that he can sell books to the entire world just from Seattle, right? He didn't have any other facility. And then he realized he was losing a lot of money shipping books around the world. So now, as you know, he has warehouses all around the world, right? Their last mile project is all spatial, how to reduce delivery time. So any big tech companies or other company that you can think of, they all have big spatial activities.
So maybe Amazon aside,
Right.
what do industry and governments need to do to realize the full potential of geospatial computing?
So the key thing is that many of us still think about this technology as if we were in last century. Last century, the dominant players in this place were like ESRI ArcGIS family, which has a few million licenses. Right? Even GPS and all were just picking up. So if you think of last century, you think of this technology having a few million users. It's a small niche technology compared to internet, right, and everything else. But it has changed, with smartphones, right? Every smartphone has location, and this is one of the dominant use of smartphone. So now we have billions of users for navigation apps, right? Billions of users for ride sharing. And now many other such applications can be developed. So people should kind of first of all realize this is much more pervasive than they might imagine. It goes well beyond the smartphone. Actually, anything that has a clock, power grid, telecom. If you have a clock, you should realize that most clocks are now based on GPS signal. Okay, if GPS goes out, most of your essential infrastructure, the clocks will be out of sync. So, so this is something to realize. Things have changed. It's a very silent revolution. It's a huge revolution. The next revolution that seems to be taking place today is the exploitation of remote sensing data. And this is something to watch for. Next 5-6 years, you will see big things happening there for 2-3 reasons. Right? One, the data collection has gotten cheaper. We have nano satellites, right? Your probably audience will know that. So single rocket can send 100 nano satellite up. So with those, already there are companies like Planet Lab, which can scan the Earth every day at meter resolution. This is only the beginning. And once you have that kind of data, you can do very nice things. So for example, after Arab Spring, 82 countries have signed an agreement to monitor worldwide crops, 4 major crops. So every week or so, there is a report and we know which area crops are doing well or not doing well, right? And then they can do a number of things. The government wants to reduce food shortage, so they can take early action. But if you imagine commodity market, right? The food companies, all the commodity trading now has to look at this data. So you talk to any large food company, they're all looking at GeoGlav data every other week because it will affect their prices, right? So this is everything. So this remote sensing thing is just starting. You can monitor other things, which and startups are happening, like World Petroleum Inventory. It turns out that petroleum storage tanks, their roofs float on the oil. So as the oil goes up and down, the roofs sink and float, right? Go up, and the length of the shadows change, and you can see that from satellite imagery. So there are companies which actually analyze that and give you an estimate of world petroleum inventories. And again, you can imagine the oil market, right? With China coronavirus, you already saw oil dropping. So people have much better assessments going on. Even retail, people are now monitoring traffic in the parking lot of retail stores to do a number of things. For example, when Walmart came to Twin Cities, where the dominant retail was Target, they had to choose where to put the stores. The first thing they do is to look at the imagery of the parking lots of Target to know which stores have high traffic, and they start there. But now this is being done, for a very large scale. In many US retail stores, their parking lot traffic is monitored routinely via these remote sensing satellite imagery. And that data is fed to Wall Street and other markets. So these are just the beginning. Just try to imagine what we can see from space, right? You can count every building, you can count the vehicle. Probably not there to count the people yet. It's not far though. There are other platforms where you can actually count the people also and track them.
Dr. Shashi Shekhar, McKnight Distinguished University Professor at the University of Minnesota. Thank you so much for joining and doing a deep dive on your work. If somebody wants to connect with you, how can they do that?
Sure. So there are two, I guess, proper ways. One, I have a website through University of Minnesota. It's www.cs.umn.edu/tilde-Shekhar, SHEKHAR, or you can just Google my full name, Shashi Shekhar, University of Minnesota. It will take you there. And that site also has my email if you had very specific questions. And also a book, that I'm authoring, Spatial Computing. That's coming out through MIT Essential Knowledge Series. And that would also have a lot of detail and further information to connect with not only me, but other people in the area.
Well, there you go. And you can always count on Google for all that information. And find more of my interviews right here or at tonyahall.net. Thanks for watching.